Today I'm going to show you how to convert a percent composition into an empirical formula. When you read through a question or you get some data on a substance, you might find that you know what percentage by mass of each element is in the formula, but you don't know the actual formula. And we know from the readings that if you don't know the actual formula, you can have very different substances. For instance, there's carbon dioxide and carbon monoxide, both made of carbon and oxygen, one of them being very, very dangerous to you, and one of them is not. So, the first thing that you need to know in order to do this, you have to be given either the percents of the composition or the mass, the composition by mass. And then the next thing that you need to do is you need to get the atomic masses of each substance. So from the periodic table, I know that 1 mole of sodium is 22.99 grams. And I know that 1 mole of sulfur is equal to 32.066 grams. That's the first item that you need. After that, we have to start with masses. We have been given percentages. So if you're given masses, you're ready to go. If you're given percentages, all you have to do is drop the percentages and put grams next to them. And you can just assume that this is out of 100 grams, and the percentages and the grams will match up perfectly. So I'm going to write down 58.87 grams of Na and 41.13 grams of sulfur. Using our mole to gram and gram to mole conversions, we're going to convert both of these gram values into moles to get the mole ratio of the substance. So in order to convert to moles, we're going to cancel out grams by putting grams in the denominator. So 1 mole of sodium is worth 22.99 grams of sodium. So 22.99 grams will go in the denominator, and 1 mole will go in the numerator. We're going to divide 58.87 grams of Na by 22.99, and we will get a value of 2.561 moles of sodium. Let's do the same thing for this one. 41.13 grams of sulfur. We're going to convert that by using the ratio from the periodic table. 1 mole of sulfur per every 32.066 grams of sulfur. We will divide these numbers just like before, and we get 1.283 moles of sulfur. So the ratio between them is 1.283 moles of sulfur per 2.561 moles of sodium. Unfortunately, those are not nice numbers, so we will take one more step to convert them to nice numbers that we can make a formula out of. So let's move this upward. And all we do is set up each one of these and divide them by the smallest mole amount. And in this case, we only have 2 of them, so we're going to divide by this number. And that will convert them to whole number ratios or very close to it. So 2.561 moles of Na divided by 1.283 will give us 1.996 moles of Na. And that's not 2, but it's really, really close. And we're looking for whole number values here, so we can round that to 2. Your decimal, if you don't get a whole number, should be so close to a whole number that you can divide it, or round it, excuse me. So 2 moles of Na. The second one, of course, would be 1.283 moles of sulfur divided by 1.283 would give us The same number divided by the same number is, of course, just 1 mole of sulfur. So that means it's 2 moles of sodium per every 1 mole of sulfur. The formula should be, putting the metal first and then the nonmetal, Na2S. This is the empirical formula showing the basic ratio of how these elements are combined. 2 NAs per every 1 S. And we got those numbers by dividing out there.